All right, guys, so this is the last part of the final exam review, all about linear programming. Okay, so this first one says, which of the following provides the correct graphical representation for the system of inequalities below? Okay, so we just need to make sure we pick the right, essentially shaded region, because if you look at all the answer choices, they're all the same lines, it's just the shaded regions are different. Okay, so if we look at this first one, it says y is less than or equal to 8. And sorry for the blurriness slash crookedness. But anyway, it says y is less than or equal to 8. So y lines are horizontal lines at 8. So like this line here, this line here. So that's that line, and then less than means shaded below that line. So we can automatically cross off B, because you see how this is above the line 8, not below it. So we know that's not the right answer. And same thing with D. Look at D. Also, you see how this is also above the line, not below it. So we can cross off that as well. But these two, this is below the line and this is below the line. So it's one of those answers is the right one. Okay. Let's look at this next. I'm so sorry. This is so crooked. There we go. So let's look at this next one. 1/4 x plus 6. So that's going to be these types of lines. Remember, you start them at this number right here, and then this is the slope. So you would go like up 1 to the right 4, up 1 to the right 4. So that's this line right here. That's starting at 6. And then same one down here, right? The one starting at 6. So really, that's going to be the one that decides it, because you see how for this one it's shaded below the line, and then for this one it's shaded above the line. So that's going to tell us which one. And so let's go back and look. So that one is less than or equal to. So that means we need to shade below the line. So it's going to be A, because this is shaded below that line, versus C, it's shaded above the line, and that's not what we want. We wanted below the line, so it has to be A. So yeah. All right, number 2. So we're just solving. This is so blurry. I'm so sorry. My camera is not very good, but hopefully you guys can kind of see what's going on anyway. So this one says solve for y. Okay, so we're just trying to get y here by itself. So really what we're doing is we're doing the order of operations. I think Coach Klein said this in one of the videos he made. You're doing PEMDAS backwards, right, when you're solving. So you always want to move the subtraction and addition stuff over to the other side first, and then you'll like multiply or divide something to the other side. So let's look. We're trying to get y by itself, so we need to move what's like added or subtracted to it to the other side first. So we actually need to move this w squared to the other side first. So here, let me work this out over here. So we have w squared minus y squared equals z squared. Okay, so we'll subtract, let me get a different color. We'll subtract the w squared to the other side. So that cancels, right? And just be careful, this is a negative y squared. Some people think they can drop the negative, but like you can't, you have to bring it down. And so this is z squared minus w squared. You can't combine those, right? They're not like terms. Okay, and then you guys, you can't get y by itself by square rooting yet because of that negative in the front. So what you have to do is that's really like a -1 in the front. So you got to divide everything by -1. And what happens is that everything flips signs, right? So this changes to a positive y squared. This will change to a negative z squared, and this will change to a positive w squared. And you can see the answers. Do you see how it doesn't say negative z squared? Like they flipped it. So what they did in the answer is they put w squared minus z squared. They like to do that because they don't like to leave the negatives in the front sometimes. So anyway, they just kind of flipped the order. But anyway, and then the last step would just be taking the square root of both sides. And when you take the square root, remember you have to put plus or minus in front, and that's just w squared minus z squared. And I know some of you want to go ahead and take the square root and put w minus z. You cannot do that. You cannot take the square root of because these are like together. You can't just like separate them and take the square root and ignore this negative. Like that's not how it works. Okay, so you're just gonna leave it like this. So the answer is B. Okay. All right. Next one says solve S equals 1/4 TU squared. So we're just solving for T. Okay, so some people don't like these kinds because of the fraction, but you guys don't freak out when you see a fraction. Fractions are pretty easy. All you do is you multiply by the reciprocal to get rid of it. And the reciprocal of 1/4 is just 4/1 or 4. And that gets rid of it. Okay, so that's what you always want to start out doing, getting rid of that fraction. So we have 4s equals TU squared. And I know some people are tempted to like take the square root here, but we don't have to do that because we're trying to get u by its, or not u, t by itself. So we just need to move that u squared to the other side. So we just need to divide it because these are next to each other like this with no add or subtract. That means they're being multiplied. So we just need to divide it to the other side. And that would leave us with t, right? So t equals 4s over u squared. And that's it. No square roots or anything. Okay, so pretty easy. All right. All right, moving on to like some linear programming. Those weren't really linear programming. All right, linear programming. This one says a movie theater sells tickets at a children's price and an adult price. The cost of the children's ticket is $4. The cost of the adult ticket is $7. Each theater has 120 seats. Each movie should sell at least 12 children's tickets and at least 40 adult tickets. For this problem, X is children's tickets and Y represents adult tickets. So it says, what is the objective function that should be used to maximize profit for the theater? So we're just trying to think about how much the theater is making. So let's think. The cost of the children's ticket was $4, right? An adult ticket is $7, and the cost is what the is like the profit that the movie theater is making, right? They're making $4 for every children's ticket, $7 for every adult ticket. So those are the two numbers that are going to go for the profit function, the objective function. Okay, and so you're going to have 4 goes with children, which remember children's is x. So 4x, and then 7 needs to go with y then. So it's 4x plus 7y. So hopefully that makes sense. All right, and objective functions you guys are normally pretty good at. So hopefully you get that part. Okay, so then 5 says, which of the following represents the constraints for the theater? Okay, so let's think about it. It says each theater has 120 seats. So it doesn't really tell us like anything else. And I always tell my kids, like, you know, kind of like a little cheat is that when it just gives you like a single number and it's not talking about like one of the variables, like if it's not talking about just children's tickets or just adult tickets, it just gives you like a single number that is unrelated to those, then a lot of the times your equation is going to be x plus y, and it's going to be like not equal to, but one of the inequality signs and then 120. And the reason is because x is the children's ticket sold, Y is the adult ticket sold. So all of those sold would be how many seats you could have in the theater, right? So the adult tickets and the children's tickets has to be less than or equal to 120, right? Because there's only 120 seats in the theater. So it has to be either that number or less. Hopefully that makes sense. And you can see that's kind of like the first one here. But they went ahead and solved for Y because when you graph it, you have to solve for Y, right? So the way you solve for Y is you move that X to the other side, and you get negative x plus 120 here. And the only time you flip the inequality sign is whenever you divide by a negative, which we did not do. So it's going to stay less than or equal to. And so we can cross off B and D right off the bat. It's going to be either A or C. And so then we just got to decide about these single variable ones, okay? So this one says each movie should sell at least 12 children's tickets. So you see how that one is talking about something that a variable is talking about. So that's going to be just like the variable in either less than or equal to or greater than or equal to that number. So we just got to decide. So first of all, children's tickets is talking about X, right? So it would be X is at least. At least means it has to be that number or more. So greater than or equal to 12. Okay, and then it says it also needs to sell at least 40 adults. Well, adults, remember, is Y, and then at least, once again, is greater than or equal to, so 40. So that is C. The answer is C. Okay, hopefully that made sense. All right, this says, suppose the objective function to represent cost is this, gives you the objective, use the graph to determine the minimum cost. Okay, so remember, to find like mins and maxes here, we just have to take the vertices of the shaded region of the feasible region, and we just got to plug them into the objective function. So really this only has 2 points here and here that are vertices of this shaded region, because this shaded region will keep going on and on forever this way. So these are really the only 2 points. So that's 4, 6, right? This point is 4 and then up 6. And then the next point is 4 up 7, I think. So, I mean, obviously 4, 6 is going to be smaller than 4, 7, but I'll go ahead and plug them both in. So you just plug this number in for x and this number in for y. So we'll have 4 times 4 plus 3 times 6, right? I just plugged in this 6 for the y. And then same thing here, 4 times 4 plus 3 times, and then this time the y is 7, which obviously is going to be more than the other one. But anyway, 4 times 4 plus 3 times 6. So the first one is 34, and the second one 3 times 4, or 4 times 4 again, plus 3 times 7. It's 37. So obviously the minimum one is 34. Okay. All right. All right, and then this last one, this is like a full-blown problem here. And since you guys are going to have, normally I would show you on, you know, I don't know why my throat just got dry, but normally I would show you on a piece of graph paper how to do this. But, you know, since you're going to have access to Desmos on the final, I'm going to show you how to put this in Desmos. It's actually very, very easy. And I think some of you are overthinking it. So I'm going to show you how to put it in Desmos. And actually, you know how like that one above here, how we had to solve for y here to graph it? Well, you don't even have to do that for Desmos. Like you can put it in as its original form and Desmos will still graph it. So it's like much easier if you just use Desmos. So I'm going to show you how to do that. But first things first, we're going to go ahead and, you know, write the objective function and write the constraints. Okay. So this says Dominic is starting his own side business where he makes side tables and coffee tables. It takes him 2 hours to make a side table and 4 hours to make a coffee table. So when I read these, I like to go ahead and underline things with the same units. So you see how this is 2 hours, this is 4 hours. So I'm going to keep looking and seeing if something else says hours. It says since this is a side job, he only has 20 hours he can spend making his merchandise. In addition, he can only get enough materials to make 8 products per week. He makes a profit of $30 and $50. What is the maximum profit he can get this week given the constraints? Okay, so first things first, I like to do if you want to do the whole thing, let's go through and do the whole thing just in case. Like, who knows what the final is going to ask? I mean, I do because I made it. But first things first, let's see what the x and y represent. Okay, so really, you just have to think about the 2 things you're talking about in the problem. And so in this, we're talking about him making these side tables and coffee tables. So x would be the number of side tables. Yeah, that's the first one. Side tables made. And y will be the number of coffee tables. Is that how you spell coffee? Yeah, coffee tables made. Okay, so that's kind of, you know, just a side note. Some people like to skip that step, but, you know, I like to write it down. Okay, and then next step, I'm going to write down the objective function. Objective function. So I like to do that first just to get that out of the way because I think it's pretty easy to pick out these numbers. So the objective function numbers are going to be the numbers that say like he makes a profit of this, or like in the one above it was like how much the movie theater's making, or you know, there was one on your review that was about how many points you're getting on a test. It's like what you're profiting, what you're making, what you're getting, right? And so I mean, most of the time they literally say the word profit. So this is, we're making a profit of 30 on the side table and 50 on the coffee. So this would be 30 x, because x is side tables, plus 50, and then y, because y is coffee tables. Okay, so that's the objective function. We use that in the end, right? And then the last thing I'm going to do before we hop on over to Desmos is write the constraints. Constraints. Okay, so for the constraints, so you can kind of see I already underlined some of those things that matched, right? 2 hours, 4 hours, 20 hours. So when things have the same units like that, they go together in an equation. So like the first equation would be 2x plus 4y, and he only has 20 hours to make these. So he only has 20, that means he has less than or equal to 20. Can't spend more than 20, right? Okay, and then the only other information it gives us is that he can only get enough material to make 8 products. So it's saying 8 products. It's not saying 8 coffee tables, 8 side tables. It's not being specific to like one of the things he makes. It's just saying 8 products. So whenever it's just like saying in general, and not being specific, then your equation is gonna be x plus y because it's both products together. Okay, and he only has enough to make 8, so that's less than or equal to 8. Okay, and then I always tell my kids, you always really, unless you already have something that says x is greater than or equal to or y is greater than or equal to, you have to put is greater than or equal to 0 at least. If it already has something, then you just don't put that. But if it doesn't have anything, you have to put greater than or equal to 0 because you can't have a negative amount of coffee tables or side tables. So you have to put that as one of your constraints. Okay, so I'm going to hop on over now to Desmos. So let's see. I have to share my screen. Give me a second. Okay, I think, oops, I just went over to my mail. All right, so I think you guys can see my screen now. Okay, so what I'm going to do is, see, this is telling me I'm presenting, so I should be able to see. Can this go away? All right, so what I'm going to, you guys, okay, okay, I'm presenting to everybody, right? You're presenting to everybody. Yes. Okay. So you guys, why does it keep saying that? All right, I'm just gonna ignore it. Okay, so now you're gonna type in your constraints in here. And like I said, you can go ahead and solve for y, but you don't even have to. Desmos, if you just type it in, 2x plus 4y, and you can't really put less than or equal to, but you can just put less than. It's just like shift and then the comma button. You hit shift comma. I can't really show you that, but hopefully you can figure that out. It gives you a dash line, but because you can't type it, I don't think you can type in great. Oh yeah, you can. I'm a lunatic. You can. Less than or equal to is right here. If you click this keyboard thing, there you go. All right, so there it is. You can just type it in exactly how it looks, and it even shades it for you and everything. So you just do that for all of the things. X plus Y is less than or equal to 20. No, 8. 20 was the other one. All right, and then x is greater than or equal to 0, and y is greater than or equal to 0. Okay, so I know that's really hard to see, but the place that's shaded, I mean, you can look and you see how all these are kind of individual colors, and then this one's kind of like a hodgepodge of colors. So this is going to be the like main shaded region. And if that confuses you, you can just kind of think about it as like, you know how these two are less than. So that means these 2 lines, these original 2 lines, need to be shaded below. And then these are greater than or equal to, but that just means we can't be in these negative quadrants, like any of these negative quadrants. So since these are shaded below, it has to be this section here. Okay. So for that feasible region, we have this point, oops, this point, and this point. Okay, those are the points on the edge of my shaded region. Okay, so I'm gonna write those down and I'm gonna flip back over to my camera. So 0, 5, 0, 0, 6, 2, and then 8, 0. So hopefully you can see, please use Desmos. It is much easier. But you can get graphing paper if you want. If you're just the kind of person that likes to do it by hand, I like to do that. So, you do you if you want to do that. Okay. All right, let me stop sharing. All right, back here. Okay, so I wrote down the points I got right there. And then all you're going to do, the last step, is to take these points and you plug them in. Oops. And you plug them into the objective function. Okay, so you'll do 30 times 0 plus 50 times 5. And then 30 times 0 plus 50 times 0. You're just plugging in for x and y, right? 30 times 6 plus 50 times 2, 30 times 8 plus 50 times 0. And you just plug these into the calculator, okay? So the first one, 30 times 0 is just 0, so I'm not going to plug that in, but 50 times 5 is 250. Okay, the next one's 0, right? 0 times 0 times 0. Okay, 30 times 6. 6 plus, 50 times 2 is 280. All right, and then 30 times 8 plus 50 times 0. I don't even know. I just typed in 50 times 0. So that's 240. So clearly this results in your biggest, right? Your maximum profit. So you would say he should make 6, and then X, remember, was side tables. 6 side tables and 2, remember, Y is coffee table, so 2 coffee, I don't even know if you can see this. My hand's probably covering it, but coffee tables to make max profit of $280. Okay, so hopefully that makes sense. And you feel a little bit better about linear programming. So that's the end of the final exam review. So you guys are done. Well, maybe not if you went out of order, but you're done with this section anyway. So good luck, guys.